I I was just walking past Fen Ditton and I saw I heard what I thought sounded like raptors' cries, and I couldn't see anything. I was looking in the trees, and I met this girl walking her dog, and she said, "Look, there's 3 buzzards up there," and they were flying over Fen Ditton. She said, "You don't usually see 3." I said, "Oh, maybe they're having a fight." But then when I didn't get a picture of it because they'd gone, they were just there for a minute or two. She said she thought it was a good sign. I thought so too. And I was a bit worried that that last blog post I made, that somebody's going to start trying to do some kind of arms race with trades before they even get to the stock exchange. And I guess if you do that with the aim of trying to smooth, I don't know how it works. I don't know how these networks interact. I noticed when I was looking at those videos that YouTube are doing some quite clever things now. Well, they were obvious actually. It's just taken a long time to get it to work, obviously. And they're prioritizing the audio and dropping frames. So there is some kind of quality of service stuff working still. I wrote an article for the Center for Mathematical Sciences Asymptote magazine, which they published while they were fundraising for the Center of Mathematical Sciences. That was when I worked for Peter Lanzov and Richard Gibbons, and Frank Kelly had written this paper on the statistics of internet quality of service mechanisms. And I kind of tried to read the paper, didn't understand it, and talked to them about it. And wrote an article for Peter Lanzov, so it was published sometime in 1999 in the Asymptote newsletter. I should look it up. And I don't know what they were doing with Functor Includes. Maybe it's I had the idea that standard ML didn't need any higher order functors. I thought that what you could do instead was modify the build system. It actually has a module language where you specify how to compile modules together. And I thought all you needed to do was close the loop in that language. I've forgotten what it's called. The SML. It's the SML basis something. Not the basis library, which is a kind of runtime well, I think of as the kind of runtime interface to the hardware. That the basis library gives you things like vector arrays and all that good stuff, and also basic operating system interfaces for opening files and closing them and scanning tokens out of files and things like this. But what I thought was that you could do the meta-programming stuff by writing standard ML, which output source code, which was then read and compiled by the standard ML compiler. And that way you can still do all of the static type checking on the modules without any kind of inconsistencies, because I really don't understand how higher order functors type systems are consistent or decidable. I'm completely out of my depths. You'll have to ask what's his name? I went to work for Microsoft Research. The guy who he worked at the computer lab, and for his PhD he put the higher order functor stuff in Moscow ML. I've forgotten his name. His Italian name. But it is very carefully designed, standard ML. And it may not have been kind of intentionally targeted at mathematics or category theory, but certainly most of the people that worked on it know quite a lot of category theory, and this is going to have influenced them. And what I found with, I mean, maybe it's about experimental mathematics. When you build a mechanism, it might be quite hard to explain that mechanism mathematically, but you can understand it intuitively as a mechanism. And it may be difficult to prove things about it, but it's still quite understandable as a mechanism. So, like, I don't understand any of Nathan Delaclas' formalization of that F something stability or whatever it is of finitely irreducible conformal graph directed Markov systems. But when I figured what the mechanism is that they were talking about, it was interesting. And understandable. So the maths is often stratospheric when the mechanical objects are actually quite simple. But definitely I wouldn't try and understand the mathematics without a good intuition of the mechanical model. And that's why I want to get hold of my regular expression library, because what I did in that was for non-deterministic finite automata only. I wasn't able to do it for deterministic ones, because the way I handled deterministic automata was by converting a non-deterministic one into a deterministic one using the subset construction. But for non-deterministic, I was able to add self-referential backtracking or self-referential back references. That is, within a back reference, you could reference itself or any other recursively which referenced itself, and it worked. I mean, it didn't produce readable. It didn't result in kind of easily understandable expressions, but all I did was, I think every time I re-entered the piece of regular expression syntax which opened a group, you use curly braces to open a group which you can later back reference by just backslash on a number, which is the level of the open parenthesis in the preceding expression. So you can have something like open curly brackets which starts group 1, and then you can recognize some A's and B's, so A, B, and then you can say backslash 1, and you're referring to the pattern that you're currently matching. And I think what I just did was in the matching code, I had a push down list or a stack, and I just stacked pointers into the input stream indicating where that part of the match was occurring, and then when I was matching against a backslash 1 reference, I simply counted, before I dropped it out of the subset of current possible states, I counted along the currently input text by the current counter for that level, and I dropped it from the list of possible states as soon as that didn't match the current input. That's not going to be very easy to understand unless you've played around with this idea. But it seemed to work. It didn't crash, and it recognized things. And I have a vague memory at one point of getting something like a list of Fibonacci number. I was trying to work out what you could match with this stuff, and I seemed to end up with one expression which matched Fibonacci numbers of A's. But that may have just been a dream. So that's why I've contacted Peter Kelway and asked him if he could dig through his old 3.5-inch floppy disks and see if he can find a copy of my regular expression library. But he said at the moment his life was more exciting than mine was in migrant detention, so it sounds like he's having a bit of a rough time. I might have given Nick Shaler a copy of that code at some point. Nick Shaler went to work for Sun Microsystems and then I guess ended up at Oracle. So that's all I got to say about that. This one's gone.